Hi everyone, I am going to discuss electrochemistry, which is a very important one. But before electrochemistry, I just want to cover oxidation, reduction, oxidizing agent, reducing agent, redox reaction, these things. Because without this information, you can't handle electrochemistry, okay? So I am going to discuss first oxidation number calculation. So if you are going to find oxidation number value, so you should know a few things. The first point is that when any element is present in its elemental form, like suppose I am saying nitrogen, N2, like Cl2, Br2, I2, C2, O2, something like that, they all have zero oxidation number. Means oxidation number you can calculate in a molecule or in a compound, not only in elements. Okay, so any element is given in this way, then we can say it will be zero. Now the second point, element of first A group element like lithium, sodium, potassium, rubidium, cesium and hydrogen, they all have +1 oxidation state. They all have +1. Similarly, if you have second A group element, magnesium, calcium, strontium, this one, they have +2. And similarly, third A, you can select boron and aluminium have +3. All the halogen, fluorine, chlorine, bromine, and iodine, they have -1. And generally oxygen have -2 in oxides. So I will apply this information in the question. Suppose you have H2SO4 and we have to find the oxidation state of sulfur. So as you know, in the table, the hydrogen oxidation number is +1. The hydrogen has +1 oxidation state. So we will do 2 into +1. We have to find sulfur, so we can assume this one as X. Oxygen is 4 times, so we can write 4 into. Now oxygen oxidation state is -2, so -2, that is equal to 0. So as you can see, this is 2, this is X, this is -8, that is equal to 0. So X will be +6. So this is +6. We can find KMnO4, Mn, and potassium +1 because it is first A group element, +1 plus X +4 into -2, that is equal to 0. So you can see X will be +7. So this will be +7. Sometimes you have a charge. Suppose you have MnO4 negative -2. Then what is the value of Mn, oxidation number? So you can see X +4 into -2 is equal to, this charge will be put here -2. So X -8 is equal to -2. And when you will solve this one, you can see X will be X will be +6. So this one should be +6. So this is the method where you can find your oxidation number. Okay. Now what is oxidation? I am saying loss of electron. Loss of electron is oxidation. Means suppose you have element A, when it will lose the electron, that will generate a positive charge. So this is known as oxidation. Or there is another definition, increase in oxidation number value will be oxidation. So you can see here A has 0 because it is present in elemental form, and this is +1 charge, so we can say this oxidation number is +1. So it's increasing 0 to +1. So 0 to +1 means we can say increase in oxidation number, so that's why this is oxidation. Now we can talk about reduction. Reduction means, suppose I am saying, yeah, gain of electron is reduction. Means A will take an electron and that will convert into A negative. So we can say A is gaining the electron, so A reduction. And there is another definition, decrease in oxidation number, decrease in oxidation number is reduction. What does it mean? You can say this is 0 and this is -1. It means when you will move 0 to -1, decrease in oxidation number, so that's why this is a reduction. So reduction is a gain of electron or decrease in oxidation number, while oxidation is a loss of electron or increase in oxidation number is oxidation. Now thing is, what is redox reaction? Redox reaction. Redox stands for reduction and oxidation. Reduction plus oxidation. So we can say when reduction and oxidation both occurs in a chemical reaction, we can say it will be a redox reaction. Suppose you have a reduction reaction, copper +2, that will take 2 electron and it will convert into copper. You can say this is reduction. Why? Because it is gaining electron as well as decrease in oxidation number. And there is another reaction, zinc. Zinc will convert into zinc +2 by losing 2 electron. So this is oxidation. And when I will add these two reaction, you can say here 2 electron, here 2 electron, both will cancel out. And this should be copper +2 plus zinc, which is equal to copper plus zinc +2. So now you can see in this chemical reaction, copper +2 to copper. Copper here +2 form and here 0, which means decrease in oxidation number. Decrease in oxidation number, so we can say it is reduction. So here the reduction of copper +2 is happening. And if you look at zinc, this is 0 and this is +2. So we can say zinc will oxidize, means increase in oxidation number. So we can say it will oxidize. So oxidation. Any doubt about this? I don't think that it is very clear. So when reduction and oxidation occurs in a chemical reaction, then we can say it is a redox. So this is a redox reaction. Now the term is, what is reducing agent and what is oxidizing agent? Suppose I am saying zinc convert into zinc +2 by losing 2 electron. We know that it is an oxidation of zinc. So if it is an oxidation of zinc, because it is 0 to +2 form, means increase in oxidation number, so this is oxidation. So whenever self oxidation, you can see here zinc is oxidized here. So whenever self oxidation, it means that element or atom will behave as reducing agent. So here zinc oxidizing, so it will act as a reducing agent. It will act as a reducing agent. And suppose I am saying copper +2 by it will take 2 electron to convert into copper. This is the reduction reaction. So copper self reduction here, reduction, it means if copper self reduction, then we can say it will behave as a oxidizing agent, oxidizing agent. So self oxidation, reducing agent, self reduction, oxidizing agent. And you know that this is our chemical reaction when I has, suppose this is zinc, zinc plus 2 electron, copper plus 2 electron converts into copper. This is oxidation of zinc and this is reduction of zinc. So when you will add this reaction, you can see 2 electron will cancel out. So zinc, copper plus 2 convert into zinc plus 2 and copper. So you can see here, zinc converted into zinc plus 2, it means oxidation. So here zinc is a reducing agent. Zinc is a reducing agent. Similarly, copper plus 2 is converted into copper by gaining 2 electron. It means this is reduction. So copper plus 2 is reduction. So we can say copper plus 2 will behave as oxidizing agent. Okay. And there is another thing I just want to clear. I'm talking about, suppose you have electrochemical series. I'm talking about electrochemical series. Here we have few elements in this series. There is no need to memorize this. It is basically like, concept. And suppose you have a hydrogen here. It has zero potential. This is E naught. It is a potential of elements. So here hydrogen has zero potential. Below hydrogen and above hydrogen. So below hydrogen we have copper, we have Br2, we have I think we can pick here. Wait. Yes, we have this electrochemical series, suppose. So you can say here hydrogen has zero potential, zero E naught. And there is a two type of thing. This is hydrogen. This is above element, suppose any element X and any Y. This is above to hydrogen and this is below to the hydrogen. So the thing is that whenever you have a positive value of E naught, positive value, it means it is a reduction potential. This is a reduction potential. And negative value means oxidation potential. Oxidation potential. The thing is very simple here. If it is a reduction potential and if it is a oxidation potential, so it means X will self-reduce. So we can say self, I can write here. Hydrogen, which have zero. There is X and Y. This is above to hydrogen, so we can say this is reduction potential, which is a positive value. Whenever positive value, reduction potential. And this is a negative value, which means oxidation potential, negative value. So X has reduction potential. It means X self-reduce, self-reduce. Y has oxidation potential, so we can say Y is self-oxidize, self-oxidize. If Y will self-oxidize, it means Y can act as a reducing agent. Reducing agent. And this is X is self-reduced, so X will act as oxidizing agent. So X is an oxidizing agent, it means X can oxidize hydrogen. Okay, because above the series means it can oxidize to the below one. It can oxidize this one. Oxidize. And it can reduce to hydrogen, which is above to this element. Okay, so we can say Y is a best reducing agent. And X is best oxidizing agent. Suppose we have this type of series, hydrogen 0, we have above A1 and A2, and in the down we have B1 and B2. So you can say these some values will be given. This is positive value of reduction potential, and here you have a negative value of oxidation potential. So you can see this is a very highest negative oxidation potential. It means it is a best reducing agent. Best reducing agent. While this one is a best oxidizing agent because it is present above, you know, best oxidizing agent. So this is all about electrochemical series. So if you look at this question, you can say here, hydrogen has 0. So zinc can reduce hydrogen because zinc is present down. Only zinc can, because every element in this table is above to the hydrogen. It may be Cl2, Br2, I2, copper. Only zinc is present below in to the hydrogen, so zinc will reduce to the hydrogen, while all the halogen, chlorine, bromine, iodine, and copper will oxidize to the hydrogen. And there is another information I just want to tell you. Suppose I am talking about the nature of chlorine and bromine. You can say chlorine has highest value of positive plus 1.36. So chlorine self reduction, I already told you, it means best oxidizing agent. So chlorine can oxidize anyone, Br2, I2, anyone, but Br2 cannot oxidize chlorine. The reason is that Br2 is present down to the chlorine, so Br2 can oxidize iodine. Okay, Br2 can oxidize iodine. So if you look at 29 question, you can see here, which of the following will takes place if Br2 is added to a solution that contains Cl minus and iodine minus. Suppose we have a solution here, Cl minus and iodine minus, and we are adding Br2. As you know in the table, this is chlorine, this is bromine, this is iodine. Iodine value is, you know, 1. I think 07. Yeah, 1.07. Iodine value, sorry, bromine value is 1.07, which is lower than chlorine but higher than iodine. So if bromine is higher than iodine, it means bromine can oxidize iodine negative. Bromine can oxidize iodine negative, not Cl negative. So Cl negative is a wrong one. Br2 will be oxidized, absolutely wrong, because if Br2 oxidized, it is never be possible because reduction of Br2 is happening. So Br2 will act as oxidizing agent. So Br2 is also no. No redox, absolutely wrong. So only B is the right choice. And one more thing I just want to tell you. If you look at here, we have Cl2, Br2, I2, but in the question they have given you iodine minus and Cl minus. So maybe you can confuse. So I will clear this one here. Listen. Suppose I am saying Cl2. Yeah, like this. Suppose you have, suppose this one, A will lose the electron, A plus and electron. And I am saying B plus will take the electron and convert into B. So this is reduction and this is oxidation. Now listen me. Yes, first is oxidation, second is reduction reaction, no problem. But here the oxidation of A is happening. Oxidation of A. Because A will losing the electron. I am not saying that oxidation of A plus, no. And here B plus is reduced. So this is the reduction of B plus. So what we will say with respect to A plus and B, if A is oxidation, if A oxidation of A is happening, then we can say A plus will be reduced, means it is a reduction of A plus, a reduction of A plus. And we can say similarly, it is a oxidation of B, because reduction of B plus, so oxidation of B. Same thing we can say here in the table. You can see here, Cl2 will take the 2 electrons, so Cl2 reduction. So Cl minus oxidation, oxidize. Br2 reduction, so Br minus is oxidized. I2 is reduction, so iodine minus will oxidize. Simple. So now you can eliminate your option very, very easily. You can see here Cl minus will be oxidized. Yeah, the term is right. Cl minus will oxidize. Perfect. But it will not oxidize because it is present above to the bromine. So Cl minus will not be oxidized by bromine. If you look at C, Br2 will be oxidized. This is a wrong line. Br2 will not be oxidized. Br2 will reduce. So C is a wrong thing. And iodine minus will be oxidized. This is correct line. So iodine B is the right choice. Now we can move to the next question related to the electrochemical series. And here you can see which of the following species reduce a solution H plus to H2. Yes. So now the question is, which of the following, the question is here, which of the following species would reduce a solution of H plus to H2? Now listen the line very carefully. H plus to H2. It means H plus to H2 is a reduction reaction. So I already told you, below to the hydrogen, so zinc can reduce H plus. Zinc can reduce because it is present below to the hydrogen in the table. And if you look at chlorine, bromine, iodine, and copper, iodine, copper, and they are above to the hydrogen, so they cannot, reduce. They can oxidize, so they will not reduce. So zinc is only the element which is present down to the hydrogen. So zinc can reduce. Zinc can reduce to this. So only third should be the right choice. Now you can say this is the role of electrochemical series. Okay. So this one is a very important concept. Now I'm going to discuss another concept, that is EMF of the cell. Listen me. Suppose if you are talking about, okay, I will do another session about EMF. So I can stop here this video. I will create another video for EMF and other things. Thank you so much.